Up to now, there have been two main technologies that efficiently filter primary dirt from air in residential vacuum cleaners, namely bags and cyclones. Bags have the advantage of a simpler air path and therefore minimum inherent pressure loss, which means less energy needed to drive fluid flow. But this is more than offset by the disadvantages. They clog, requiring more power to maintain the same suction to drive airflow through the carpet pile. It's also not always clear when the bag's full. They often contain plastics, and so the disposal is environmentally unfriendly. There are non-trivial running costs for the owner over the lifetime of the machine, and they can fester dirt and stink to high heaven. The application of cyclonic filtration to residential vacuum cleaners was inspired by the use of industrial cyclones to separate sawdust in mills. Designing a cyclone that could filter very small particles typically found in household dust was a challenge, and eventually achieving this for a vacuum cleaner represented a significant step forward in filtration technology. Cyclones improve dramatically on bags by eliminating clogging, even when the bin is dust loaded, but they only operate efficiently with high fluid speed to provide the momentum for high centrifugal forces. They also offer a more convoluted air path which causes aerodynamic losses and pressure reduction, and requires a more powerful higher pressure motor to operate effectively. The cyclone assembly is also quite bulky and takes up space. What if there was a way to achieve the high levels of filtration efficiency that cyclones bring, but without the need for high airspeed, and that eliminated the need for high power motors that gobbled the battery? Well, there is, at least on paper. There's a brand new filtration technology in the works. It's essentially a spinning disc dirt separator, and research has shown that it's in fact possible to achieve cyclonic separation efficiencies using only a rotating perforated disc and completely do away with the cyclones. And it works like this. If you bring in dirt-laden air and have it strike the centre of a very rapidly rotating disc that's sealed at the edges, the air and dirt are forced out sideways in a 90-degree turn. As it's pushed radially outwards, the dirt-laden air is directly and mechanically given angular momentum by the rotating disc, causing it to fling outwards even faster. The disc has a fine perforated mesh away from the centre. Larger dirt particles that you can see can't fit through the small perforations and now have enough momentum to be centrifuged along the surface of the disc, hit the wall and fall into the bin. Smaller particles also have too much momentum to make the 90-degree turn and get through the perforations, and so are flung out as well. Very small particles that might aggregate on the perforated disc are self-cleaned by the air blasting past and are also centrifugally flung off eventually. The tiniest submicroscopic particles that can get through the perforations, and would also escape a cyclone, pass through along with the air and are handled by the filter, which remains the lightly used last line of defence. What's great about this technology is that you don't need the high fluid speed that cyclones rely on. The simpler air path and porous disc produce relatively little pressure drop compared to a cyclone pack, meaning a much less powerful motor can be used to achieve a large suction pressure at the head that drives air current through the carpet pile to do the cleaning. These efficiencies drain the battery less, and the spinning disc takes up much less space than a cyclone pack, meaning a smaller, lighter product. Dirt separation from air using rotating discs isn't a new idea, much like cyclonic filtration wasn't. In fact, I can trace particle separation from gases using centrifugal forces generated by rotating discs back to at least August 1951 in patents. But like with cyclonic filtration, this is the first time it's been successfully applied to residential vacuum cleaners. Historical use of rotating discs for filtration has also needed a cyclonic filtration system, and therefore has only been used in a complementary way. This recent research has shown it's possible to do all the primary filtration with a rotating disc alone, and achieve cyclonic performance with none of the disadvantages. Some interesting differences with this technology in a vacuum cleaner are that there's no swirl in the bin, which isn't used as a first stage cyclone anymore. A separate motor may be required to drive the disc, but in principle could also be run off the main vacuum motor. And there's loads of other devil in the detail optimizations to be researched that would take another video to go through, to do with disc seals, perforation design, material choices, air entry, bin emptying, using upside down for above flow cleaning, and so on. This technology is still in the research stage, and there are a lot of engineering optimizations still left to do on the fine details, so it's not likely to appear on the market anytime soon. Nevertheless, once solved, this technology would represent another big leap in primary filtration that achieves cyclonic advantages even more efficiently to maximise the battery runtime. Hopefully you found the video interesting and learned something in the process.